Welcome to another exciting ECE 420 readings class. Today what I'd like to do is talk about one of the positive barriers to patentability, and this barrier is called obviousness. A patent is not patentable. A patent examiner will reject a patent application, a regular patent application, if the patent examiner finds the patent to be obvious to lay people skilled in the field. So, it's not a matter of education. The people to whom this may feel obvious could all have PhDs. And so it's not a matter of, saying that lay people are people who are found on the street. That's not what they mean. Lay people skilled in the field. So if you're working in the field of glass blowing, then common people that you find on the street are not the criteria. The acid test is other glass blowers. And if you come up with a contrivance, let's say in chemistry, that allows you to create an interesting thing, let's say out of glass, let's say it's for the first time you're starting to blow tubes for cameras. Camera tubes may be very special. Maybe one of the ways in which you blew the camera tube people never thought of before. You took an Erlenmeyer flask, which has a flat bottom, you coated the flat bottom, you cut off the edge, and then you sealed it with a vacuum and put in the electrical elements in order to build a camera tube. Maybe that method for building a camera tube is new, and at the time when camera tubes were new, that was a new way of fabricating a camera tube. Nobody thought you could build a camera tube in just that way. So the method for constructing a camera tube in and of itself could have been patented, that method for creating camera tubes. So you could say, was it obvious? Well, for people today, maybe not so much. At the time, not so much, but after it was explained and people saw how it was done, it became obvious. And RCA found out about how Philo Farnsworth constructed his camera tubes, and they stole the idea. So, obviousness is an interesting thing. In hindsight, almost everything is obvious. In fact, once we learn calculus, we realize everything is easy when we know how. But before we know calculus, it's not so easy. So, this is one of those interesting things. Obvious in hindsight, prior to the application of the patent, prior to publications that may have existed in the field, it should be considered not obvious in order for it to be patentable. So obvious is such an interesting criteria. It's such a nebulous criteria, and it's so often applied as part of the office action that comes from the patent office. I thought it bears discussion, and I thought we would create a homework assignment in order to pretend as though the patent office took what's known as an office action. An office action occurs after the examination of a patent. You may not know this, but according to the America Invents Act, the Patent Office had the right to increase the number of patent examiners. The number of patent examiners has increased in the last 10 months by approximately 17%. And the time in which it takes to get your first action from the Patent Office has decreased by 25%. So the America Invents Act, in some sense, has worked. It's decreased the amount of time it takes to get an office action, and in fact, office actions are becoming far more prevalent. So, as a result, because an office action is something you must respond to, or else you lose the patent, I think it makes sense for us to think about what it would mean to write a response if we were going to represent ourselves. In the parlance of Latin, we say that is a pro se application, that is for yourself. And what happens is they give you an action which is known as a prima facie action, which in Latin means first face, or at first blush. That is, their first encounter with your exam has come up against this issue of obviousness, a barrier to patentability, and your question is, Why is this obvious? And how do I respond? And that is what I'd like to try and address today, the obviousness criterion. So one of the things that patent examiners are trained to do is identify when a patent is obvious and give you an office action if it is. And they are citing a section of our law that says a patent may not be obtained if the difference between subject matter sought to be patented and the prior art are such that the subject matter as a whole would have been obvious at the time of the invention was made to a person having ordinary skill in the art to which the subject matter pertains. What that means is, if you're creating a new cure for cancer and somebody who is going to be consulted about why this cure is obvious, is going to be consulted, that person would be somebody who is able to create cures for cancer. How many people are like that, you see? So this is a very interesting idea. Ordinary skill in the art. Ordinary skill. For one thing, most people ordinarily don't apply for patents in their field. So ordinarily, you wouldn't find somebody like that. You wouldn't necessarily say, gee, here's somebody with a PhD in X, let's say power, and they came up with this idea, and then somebody else says, well, anybody with a PhD in power could have thought of that. Wow. Maybe so. So how do I know when something is obvious, and how do I counter the assertion? So there's this thing called the Graham versus John Deere test. And sometimes what people use in chemistry is they use acid to test the properties of a material. They call that the acid test. And often they use the same term in law. They have an acid test for determining if something is obvious. So you have to look at the scope and content of prior art. This means that you have a textual analysis of what has existed in the past. So that means that if you are coming up with an idea, you have to show what your contribution is. It's very clear. The Patent Office would not allow it if you don't have something new to contribute. Ascertainment of the difference between prior art and the claims at issue. Professor Lyon has cited the Kodak patent for doing constant current through switching of resistors for a cadmium disulfide cell. And he says the only difference between what Kodak did and what he's doing is he's using an I to D converter with a lot of bits and some software that takes a log. That sounds pretty obvious to me, but maybe it's not so obvious to an undergraduate in computer engineering. So the question then is, at what level are they having ordinary skill in the pertinent art? So that's a real ordinary skill. What does it mean to have ordinary skill? That's a big question. They don't say. Often they say it's not a matter of education. They could all have PhDs. Ordinary skill. Doesn't sound like having a PhD. Evaluation of evidence of secondary considerations. So now that's another question, and you can present whatever kinds of information you like. There are historically very good ways to handle an office action. Most prominent of them is an interview of the patent examiner. Every patent examiner is allocated 1 hour for an interview for every single patent. So what that means is you have the right to call them on the phone. You have the right to take an hour of their time. But the more promising thing to do is to go there in person and have an examination in person and try and get in touch with the problems that exist with your patent. But next to that, calling them on the phone works pretty good too. So when people say historically it works well, what they mean is statistically they've gathered information about what's worked in the past, and visiting the patent office seems to work reasonably well. Me personally, I say, why not? Go visit the patent office. It's not that far away. But for some people, it could be a terrible hardship. So the examiner has to present the so-called prima facie conclusion of obviousness. That means on the face, on the first blush. This is why it's just obvious. And so they have that initial burden, but after that, the burden is on you. So they must show the case. They must make the case. In a, let's see. In a non-prima facie case, applicant is under no obligation to submit evidence of non-obviousness. Okay, so what does this mean? In the patent specification, you are not obligated to show why your invention is not obvious. On the other hand, it might make sense in the specification to explain why your stuff isn't obvious, even though you're under no obligation to do so, because it can avoid the office action to begin with. Office actions can take 6 months. So you've submitted a patent, 6 months later you get this thing out of the blue that says, it's obvious. Had you only taken the time to put in a few paragraphs to explain why it's not obvious, maybe they wouldn't have given you that office action. Maybe it could have saved you the trouble. So even though you're under no obligation to submit evidence of non-obviousness, it behooves you to do so. The prima facie case will shift the burden to the applicant. Okay, so now you've got an office action. You've got the clock, which is ticking. You, I think, get perhaps 6 weeks to respond. You can ask for an extension. You may need legal assistance if you're representing yourself, if this is a pro se application. And this is where the real costs of the patents will start to escalate, because your legal assistance may cost you something on the order of $350 an hour. That's typical around here. So once the clock starts to tick at your lawyer's office, sometimes what they do is they say, oh, we're not going to bill you, we want a retainer. This is typical. Retainers, couple or $3,000 just up front to get them started. Once they have that in the bank, then they start charging against the retainer. And when that gets used up, they don't have to bother with collection because they already have your money. I've lost retainers this way. Big, expensive mistakes. Especially retainers taken by lawyers who have a policy of no refund. So you have to be very careful about actually picking. This is an interesting point. If you're a small inventor and you have limited resources, and all small inventors do, then picking the wrong attorney will kill your business. This is a big decision, right? Don't pick the wrong attorney. Okay, remember, I told you. Then the next question is, okay, Professor Lyon, how do I pick the right attorney? And the answer is shopping. Okay, you have to be shopping because that means networking with other people in your field, going to the Inventors Association of Connecticut meeting, talking to other attorneys, talking to people who use other attorneys, getting recommendations. Don't just pick one out of a phone book. Okay, very big mistake. Let's see, there must be some suggestion or motivation to modify the reference or to combine reference teachings. There must be a reasonable expectation of success. The prior art reference or references, when combined, must teach or suggest all the claim limitations. So remember, we started today with a homework assignment that's due, and you were to write the claims. Sometimes a patent examiner will not read the patent. Shocking, right? They're paid to read the patent. Sometimes they go straight to the claims, and all they want to do is read the claims. So if there's special wording in the claims, be sure to identify all the jargon. If there's something about the claims that essentially limits the scope of the invention, even though you want to make it as broad as possible, that may be something that you can make reference to in terms of prior art. So what Kodak did is just like what I'm doing with a difference. And the difference is I'm doing it all in software. And so my claim is I'm limiting the entire scope of the invention to a method that is embodied inside of a system that can be programmed, a computer, an algorithm. So at some level, I might say, look, I'm not trying to claim what Kodak did. I'm trying to claim something just like what they did, only implemented in software. And you could say, okay, now your patent is really worth nothing, but in fact maybe it's patentable because you've restricted the claim so much. Clear rejection, if they just reject the patent, they should be able to tell you why. You know, it's obvious and here's why. Now they could say, and this might be true, right? They could say, it's obvious because somebody else already thought of it, and here is a reference that you didn't find. Right? So for example, let's say somebody comes up to you and says, I'm going to do active noise cancellation headphones and no one has ever done it before. So here I am, the patent examiner, and I type in active noise cancellation headphones. And Google says 1.3 million hits. Oh, dear. Then I say, well, let's look at the patent literature. And I go to the Google patents and I put in active noise cancellation headphones, and I find another couple 100,000 hits. Then I say, all right, it seems to me like this person hasn't really done their homework or didn't search on the right terms or did a defective patent search. So I say, it's obvious and you failed to cite all the prior work. Clear rejection. So that'll wake you up, right? So now all of a sudden you've got this problem. How do you deal with rejection, right? Office actions, can effectively make a clear rejection. If you do nothing, you lose the patent. So doing nothing is not an attractive option, unless you think the patent examiner is right. You know, you didn't click right when you did the Google search. You clicked badly. So there's this opportunity to respond. You have to take it or lose the patent. You have to write a good response. Maybe you have some business goal that allows you to say, I have customers, and this is the need that they are expressing. And for me to meet this need, an unmet need, right, I have to come up with this invention. This invention has utility. This invention is not obvious because no one else has been able to satisfy this need in the past. So if you said to me, it's been a problem that's plagued customers for years. Whenever they go out to the car, it's cold, and all the ice is on the windshield, and they have to scrape all the ice off of the windshield. So I've invented a remote starter for the car, and it works with the iPhone. And all you have to do is call the car, and the car says, hi, how are you? And you say, start yourself, buddy. And it says, okay, and it revs up the motor, and then you say, okay, crank the heat. Turn on the defroster. I'll be out in 15 minutes. And it says, yes, sir. And it turns itself on, and it turns on its heat, and you say, okay, this is an app that everybody will want. There's an app for that. And I'm going to patent this because remote starters exist, but never on the iPhone. Not before, and they don't all have control over the heat. And not only have I implemented this in a fairly interesting way, but I think it's not obvious. And it's addressing a real problem, because now when I land on a runway and it's cold out with snow at Bradley, and my car is parked in long-term parking, which means far away in the tundra, I would like a warm place to be when I get there. So being able to call it on the phone and say, hey, turn yourself on, sounds like a good idea. There's unmet need. So now I've got this invention, right? It has no implementation yet because, it's just been thought of. So I'm thinking, okay, great. Things like this exist, but not exactly the same. And so here's why they're different, and my implementation should be protected. So let's think about this. Things that drive the non-obviousness. Customers. You know, this is a funny thing. I've gone live with my Kickstarter project. I'm starting to get feedback from customers. Customers say things like, oh, it works on Dua Milanove and it works on Uno, but will it work on my Leonardo? And I said, no, it doesn't work on your Leonardo. Why not? Well, because we have to write the software for that, and it takes time. So I say, will it work on my 2650 Mega? No, it doesn't work on that either. But I'm getting customer feedback. I'm getting requests. So things that were not obvious because we have to develop the software for it, they are driving the invention. So I think that's kind of an interesting idea. If you get a phone call from the patent office, you better respond to that right away. Let's see. The examiner. The examiner is somebody you want to call after you've done a thorough search. If they've given you an office action with information about why your stuff is obvious, you better make sure you know how to respond to that when you call them up. And maybe armed with these additional facts that you've uncovered after reviewing their letter and then doing your own research, you get this opportunity to come to terms with the examiner. When you talk to the examiner, it's very important to be polite and businesslike, and then to follow it up with a formal letter that essentially responds to the office action. We spoke on the phone, this is what we discussed, and here's what we agreed to. Because that's the kind of thing that you need to be able to sort of document for the file wrapper that goes around your patent application. So patents are documented in interesting ways. The file wrapper, which is available to the patent examiner, includes the provisional patents, information disclosure documents, any correspondences that you've had, all your office actions. All of these things go, and all the fees that you paid, all these things go into the file wrapper. Not public knowledge, but the patent examiner has this stuff. So if during the course of the phone conversation you tell the patent examiner where to go, he'll document that for other examiners to see. So you better be nice. Be nice to your examiner. And remember, examiners never have enough time. There's probably 7,800 of them now. I want to say there's 540,000 backlogged patents. Right? This is a staggering ratio of patents to patent examiners. They just don't have enough time. And so they can't give your patent the careful review it deserves. That's a big deal. If you can make it easier for the patent examiner to say yes, help the patent examiner, that will help reduce the number of decision errors that can be made. So what you want if you're an examiner is you want a clearly formulated rejection, and then what you need in response to that is something that is also clearly formulated. So this is kind of like a guide to the examiner. From the patent office point of view, they have what they call refresher courses, and they put them out on the web. And these are the refresher courses that they give to their examiners. So it's nice to put on the other hat and see what does this look like from the examiner's point of view. And so that's kind of the way I like to think about it. Examiners are supposed to be fair. So if there is a criteria that is unmet, the applicant has a right to know exactly what it is in terms of the unmet criteria that they have failed to meet. Let's see, what else can we say? Who is skilled in the art? Let's see. Patent judges, I want to say they're generally not skilled in the art. Federal judges are almost never skilled in the art, but it depends what art. I mean, can you imagine a federal judge who's also a skilled software developer? Does that seem likely or even possible? Why not? Well, because they went to law school. How's that? I mean, if they went to law school, did they study calculus in law school? No. Did they get an engineering degree in law school? No, they got a law degree. How is it possible for the administrative patent judge to be skilled in the art? Can a patent attorney be skilled in the art? That's a big question. Do you want a patent attorney who is not skilled in the art? Let's think about this a minute. Suppose you have this really great idea, and I don't know, let's call it something exotic, like the cell phone. How do you explain this to a patent attorney who's not skilled in the art? You could just call from anywhere. Oh yeah, how does that make sense? Well, it uses microcellular towers. What? Right? It's just, yeah, sure, whatever. Give me a retainer. So I think what happens here is the assumption that the patent attorney is skilled in the art is not valid and has no good foundation. It may be the case that every patent attorney has an engineering degree. That may be true. One patent attorney I know has a EE degree. Another one has an ME degree. A third might be skilled in software and has some kind of CS degree. That's not all that unusual. In fact, it's quite probable that you want to pick an attorney based on where they got their bachelor's degree, because people with bachelors in engineering often go on to become patent attorneys. And many of them, if they're any good, go to work at the patent office for a while before they become patent attorneys in private practice. So that's very typical. And if after that they become federal judges, then maybe they do have some skill in the art. But the level of skill is not reflected by a PhD in anything or other. Maybe not even a master's degree in anything or other. So that's an interesting point. So when you're thinking in terms of references, old work, the Kodak patent maybe had a prior art citation. So we look at the Kodak patent, and in view of the prior art that they used and other prior art that we might like, we can do analysis. So we can make textual statements and then make an analysis. What was clear based on these things, and then what's not clear. So maybe the constant current cadmium disulfide cell resistor network makes it clear that you can get linearity in the output from your light-dependent resistor. But maybe what's not clear is how you would avoid having to build this resistor network. Maybe what's not clear is how you could reduce the costs because that resistor network adds to the complexity and component count. And maybe what we've made in our small step is a way to make it very clear. Reference numbers, claim language, these are things that you might want to put in to your response. And the question of whether or not claim language should contain jargon is open. A lot of people say you should have plain English in your claim language. But whenever I read claim language, it always sounds like legalese to me. So I know what people say, and I also know what people do, and they're very different in terms of claim language. So that's kind of where I wanted to come from on this. You know, the rest of this is detail. Some reference discloses a method that's just like what I did, except for something else. And so what I want to do is make it clear what the difference is. I'm doing exactly what the Kodak patent did, except I'm doing it in software. So if I'm claiming a software method for linearizing light-dependent resistors, I can cite the Kodak method, say what my stuff is doing that's different, and say this is why it's not obvious. Let's see now. Reference A fails to teach. Okay, a patent requires that you teach the ways that are preferred in the implementation of the device. You can't teach a way to use it or build it that is not preferred. So I could say, well, you can build a car and you can do the whole thing with just one wheel. Well, maybe that's true, but the preferred way to build a car is with 4 wheels. And so if you're going to describe the car, you better describe the 4-wheel car if that's the preferred way. You can say, oh, and by the way, the car can also be built with 2 wheels, and we'll call it a motorcycle. Say, oh, well, okay, but my preferred way is 4 wheels. So you can describe both. And you can say, oh, we can also build the car with 3 wheels, and we'll call it a tricycle. And you can say, okay, that's fine, but the preferred way might be 4 wheels. And maybe the 2 wheels can go in front of one another, or maybe they can go side to side, and we'll call it a Segway. You know, and so then you can say, okay, great, but I still want to know the preferred embodiment. What other kinds of things can be used? Claim language. Use features from references. Use the numbers from your figures. Clear statement of what would have been obvious. This should constitute a statement or explanation of how the primary reference is to be modified or combined with the teaching of other references. The statement should be specific. The way I think of it is this. You cite the specific reference, you cite maybe secondary references, and then you create the synthesis. You do the analysis and then you create the synthesis that is your invention, something different. If you said, active noise cancellation headphone technology is not new, but what is new is the use of my algorithm that no one has used before, which does fast Fourier transforms and creates a power spectral density in real time, which is then phase shifted so that only those harmonics which have power are generated in the canceling transducer. I made that up. So automatic noise cancellation headphones in the past have just succeeded because they delayed sound in the past and then amplified it with a phase cancellation. But here we're doing something different. We're taking a fast Fourier transform. That's different. And then we use that to create the power spectral density of the, we'll call it constructive interference waveform. That sounds good. I almost believe that. So now it's very clear that what you did is different, and this is part of the claim that you would make when you go to look at your invention. You're not inventing active noise cancellation headphones. You're inventing an algorithm that implements a methodology that transforms energy. And that, in and of itself, for the specific device, can be patented. The algorithm by itself, just in abstraction, according to the Bilski ruling, can't be patented. This is a recent Supreme Court ruling. You know, just having an algorithm in and of itself is not good enough. You have to make it specific to the application or machine or matter that you're trying to transform. It would have been obvious to somebody having skill in the art at the time the invention was made to modify the method of delay of sound so as to include a further step that includes fast Fourier transforms. Is that obvious? And fast Fourier transforms were taught by Winograd in 1965, or Tukey and whoever. So what would not be acceptable, therefore, it would have been obvious to someone having ordinary skill in the art at the time the teaching, at the time the reference is made, to combine to produce a claimed method. So let's see, how would I say this? First of all, I've seen active noise cancellation headphones before, but what I've never seen, and what isn't in the literature, is somebody taking a fast Fourier transform and using power spectral density in real time. And for that you need a signal processor, and that's why no one ever did it, because no one had the power computationally to spend on this kind of an activity. And maybe it's worthwhile doing it that way because the amount of power that you need to cancel the sound can be restricted to only the harmonics that have the highest energy. In other words, let's assume you have a leaf blower, and the leaf blower creates vibration. Maybe the vibration's subsonic and no one will hear it, so we'll ignore that. Maybe there's some ultrasonic vibration, no one will hear that, so we'll ignore it. Maybe we only care about the first couple or three most powerful partials, the biggest energy harmonics, and so we'll just focus on that and generate the energy for that and save a lot of energy in our system. And so we can basically knock out the first 80% of the energy that's in the audible range, and then we'll make our system way quieter because of our analysis and our synthesis and the algorithm which is unique to our invention. I have no idea if this will work, by the way. It'd be really good to have a prototype, but you know, that's not required. And this could be a really stupid idea, but that's okay, as long as it isn't obvious. So then there's this clear motivation statement. People have been using leaf blowers for decades. Initially, cave people used to just blow the leaves with their mouth. They would go, and nothing happened. But then they invented machines, and the machines were very loud. And then they had to bear the brunt of the machines, and they shed their bear skins, and they started to wear beepers and leaf blowers, and they were blowing the leaves all over the place, and suburbia has become really unbearable. So you could say, you know, I get so many complaints over the weekend because it's obvious you needed a quieter leaf blower, but it's addressing a clear need. And no one has been able to solve this problem in the past effectively. You know, and they wear, you know, what they do is they wear the earmuffs. But that doesn't make it quieter for anybody else. Only thing I can do is shut the window and not go out on the weekend, because some wahoo with the leaf blowers out there blowing junk all over the place on my nice clean lawn. So I say that clear motivation to make it quieter for others is there. You could do this for anything. You could say, oh, a jackhammer is like that too. Or maybe some construction machinery. I have no idea. So could somebody in the art have done it? Yes, perhaps. And if they were motivated to do it. But if they were simply paid as a consultant to come up with an invention, would they have come up with this invention? Maybe. But that's not the criteria. The question is whether it would have been obvious. If it took you substantial work to make this work properly, then it's for sure not obvious. I say if you know, you worked on this for a couple of years to perfect it, not obvious. You know, and that's another thing that you can cite. You know, the labor required to make this into a practical invention, it's not obvious. And once it's a practical invention, to make it manufacturable at relatively low cost so that you can bring it to market, it's not obvious. So there are all these different things. You know, I personally have a new Kickstarter project, and I'm bringing it to market, and then I think to myself, I could reduce the costs. Right now I have what they call gross sales, which is how much I charge. Then I have cost, which is how much it costs me. That includes parts, assembly, uh, all the fabrication and shipping, all the costs, and I subtract the costs from the gross sales, and I take that and I call it profit. I divide the profit by the gross sales, and I call that my profit margin. So right now my profit margin stands at about 39%. I think I could reduce my costs. Maybe I don't need to use through-hole components. Maybe I could use an automatic pick-and-place machine and use surface mount components. But that means I have to re-engineer the whole board, test it, make sure it works, maybe go through another board spin. By the time I'm done, I could have spent perhaps $400 or $800. Now the question is, how many boards are we talking? Maybe a couple hundred. It isn't worth it. Too much startup costs, right? And reducing the costs for the business. So at some level, one could say, yeah, you could reduce your costs, but if it costs too much to reduce costs, then there's not enough return on your investment. So there's all these business considerations. On the other hand, I look at something like, just the question of how you would reduce cost on something, and I think to myself, that's not enough. Engineers need to be able to have pricing power. You want to be able to charge a lot for something, especially if you're not going to make a lot of them. So it's kind of one of those things where bringing something to market is just a difficult problem. And there's a lot of opportunity for invention there. So maybe there's something to be said for describing why something isn't obvious and then to say there was a definite need for it. If I can bring the need to bear and show that no one has solved the problem in the past, then it must not have been obvious. So how can I make it so that something isn't obvious? Here's my template. Claim number 1 is rejected under section 35, subsection 103A, as being unpatentable over reference A in view of reference B. Or you could say reference A discloses, insert claim, active noise cancellation headphones. But this was found by Bose, because Bose has active noise cancellation headphones, and therefore so-and-so is not going to get an A in this class. So maybe there's something about those active noise cancellation headphones which will appear in the claim that will make it not obvious. So here are all the different possible ways in which you could reject something based on its obviousness. It would have been obvious to a person of ordinary skill in the art. Sarisha is yawning. So do we need tea? Is it time for caffeine? No? Okay. So I had this idea that maybe you guys should be exposed to this notion of obviousness that goes to the question of your contribution to society, your contribution to knowledge in your field, and that you should each be able to be very clear about why what it is you're doing is exciting, not obvious, maybe even not stupid. But not, it could be stupid, it's okay. It's just not obvious. And so that's why I wanted to bring that up. And so in order to, drive the point home, I thought I would create a new homework assignment called It's Obvious. And so in the It's Obvious homework assignment, due in 1 week, we're pretending, the hypothetical, that the patent office came back with an office action. And the office action said, it's obvious. And so now the patent office has taken an action and you are required to respond or you will lose the patent. And so your job is to take your claims and either defend them or modify them so that it is no longer the case that your stuff is obvious. And you may need to cite prior work, show what's been done in the past, and show why what you did is not the same as what was done. And you may have to use multiple citations, a primary citation and a secondary, and make a critical examination of the claim that you have made to show that this is not obvious. And your patent can be stupid, but it cannot be obvious. So what does that mean? Well, maybe nobody needs it, but it'd be better if somebody did. Or maybe, it's not really patentable because it's a law of nature. And you're not allowed to patent a law of nature. But you can apply a law of nature to do something. So, for example, you might say you would like to patent fire. That you can't do. But you could certainly come up with a new patent for the use of fire in a gas stove. Or maybe you could have a better way to use fire for building some kind of a water heater that's more efficient. So at some level, there are these things which you could do with fire that might be very good, but you can't just patent fire, I think. It's obvious, but not stupid. So that's what I was thinking about. You'll have to write something. How big should this writing be? As small as possible, but no smaller. I probably should say, if you're writing 10 pages, you're doing something wrong. If you're writing a page, it's probably okay. A page or two, certainly you don't need to do this as a big, humongous assignment in terms of writing, but you should put thought into it. So it's more about the thinking than it is about the volume of writing. What do you think of that? Yes, I think you should be able to upload. Well, does it have to be Word or should it be plain text? It's typing, because you're going to upload it to, what would be the alternative? You write it by hand, scan it, and then upload it? You're not going to just send me the facts, right? I mean, I think a word processor it doesn't have to be Word. Maybe you like LaTeX or something exotic. Word Perfect? Do people still do that? So, yes, a word processor of some sort. I think that makes sense. If you did it in, oh, I see. Maybe it should be done in PowerPoint. Ah, is that what you were thinking? Ah, PowerPoint presentation. That's not a bad idea, actually, now that you mention it. Because then we could present it to others, and we could see how we're defending ourselves. Oh, yeah, very good thinking. Yes, I'm glad you asked that question. If anyone's upset by this use of PowerPoint, well, they can wait till the break to thank him. Let's see. Use PowerPoint to defend your claims. These will be presented in class, either with you or without you, even for distance learning students. So what that means is be sure to include audio if you do not plan to attend class yourself. Right? Because I'm going to be playing this and I don't want to just sit here and read your stuff. You're going to have to do something to narrate it. How's that? Is that good? So, hey, how about that homework assignment? You guys ready to do presentations? Yes? Yes? Okay. Let's see. Somewhere in here there are student files. Really? No files? I think I did this wrong. Did I do this wrong? Assignments. I click on assignments. Okay, then I go the assignment which is due today. Today is the 19th. Provisional patent application. I click. See, I clicked on the wrong thing. Now if I click on student files, everybody, someone has not uploaded their homework. Oh, this is very terrible. Late. You don't upload? You're uploading now, but look when it was due. It was due today at oh, people are waiting till the last minute, some of them. Let's see if we can do it from the top. I'll start with Alfredo Flores, who is not here, and we'll see if we can play his thing.
I am Alfredo Flores, and today I am going to talk about the provisional patent application for a quiet leaf blower.
Can you hear that?
Why I am involved in an active noise cancellation device? Because people don't want to hear unwanted sounds. An active noise cancellation device that works in an open air and in a wide area. My idea is different because my scope of work is on the market, and I am going to use the same concept for noise cancellation from both automotive system division in a different application. My prior art are an active noise cancellation apparatus for a motor vehicle from Giddis, a wide area noise cancellation system and method from Brown, and an active noise cancellation from Curtis. An active noise cancellation device comprising a microphone, an amplifier, a signal processing, and a speaker, and these are the keys for my project.
Okay, so can somebody tell me, what is it about this device that hasn't been done before? Oh, because it's for the leaf blower. Okay, so is it the case that no one has ever done a leaf blower noise cancellation device before? We don't know. It sounds like that's what he's saying. And so there's something about this device that makes it unique. But is it obvious? What is it that they've done in the past? Some kind of wide area noise cancellation, right? Has it never been applied to anything like this? We don't know. So is there an algorithm here that makes it unique? We don't know. He's not claiming the algorithm. All he did was he claimed, well, anybody who uses any microphone and any speaker and any computer is going to infringe on my patent. That's a little broad, isn't it? Too broad. It's not telling me, it's not teaching me how to build it. It's not restricting the claim sufficiently to indicate that he's doing something unique yet. You know, you can't just say, well, anybody who does anything with leaf blowers and noise cancellation is now infringing on my patent, because maybe people have done stuff with leaf blowers before. What about mufflers? Do mufflers, are they always passive? I don't know. So this is a big question in my mind. This raises more questions than anything. We have no practical implementation. It's not clear what the algorithm is or the approach. So if I have no approach and I don't have an algorithm, it's not clear what the invention is. It's just saying, well, anybody who has any microphone and any speaker, and then that's it. They're infringing on my invention. That doesn't seem right, does it? Too broad. So we better make sure that no one has done anything like this in the past with the leaf blower. Let's see who's up next. Does it make sense to do a patent search on that? Google patents. Leaf blower noise reduction. There's certainly a lot of stuff on leaf blowers. Maybe if we could do active noise reduction. You know, there's a new Dyson sink for washing your hands, and you bring your hands in and out, and it creates a 450-mile-an-hour wind across the sink. And that's supposed to dry your hands. It scrapes the water away from your hands. And I'm thinking, you know, you could make a leaf blower that works this way. It uses this very focused air exhausts in order to be able to do what you like. So it says interior rearview mirror sound processing system. Closed loop active noise reduction. Well, maybe this is all new. I really don't know. Quiet fan incorporating active noise control. You certainly would want to cite that, I would think. And what do those claims look like? I'd like to get this in text. Oh, it says download PDF. Oh no. Oh, there it is. So somewhere in here there should be some claims. Oh yes, 31 claims. That's a lot of claims. Does he infringe on a quiet fan comprising an air-moving device having an inlet side and an outlet side? First active noise control system disposed on the inlet side and the second active noise control system disposed on the outlet side? It's a fan. Is a leaf blower a fan? Kind of has a fan in it, doesn't it? And it has active noise control. So here we have a similar thing. So it sounds like we better cite it. And we also better pay attention to what it's citing. And what year is this? 2010. This patent is in force for 20 years. So it's good till 2030. So no sense waiting for this to expire. Right? That seems too long from now. What can you do if you find your patent is infringing on somebody else's application? If you're infringing on somebody else's patent, you can either license it or you can move on and come up with a different set of claims. Because right now, it's looking an awful lot like Alfredo's patent is infringing directly on this. Do you need to have notice before you're infringing on a patent? The answer is no. You can unknowingly or knowingly infringe on a patent. If you want to get triple damages, you must give actual notice. But anybody could be infringing on a patent of yours, and you wouldn't know it. and they might not know it. So unintended infringement on a patent is still patent infringement. Actual notice must be given if you want to seek triple damages and take action in court. Alfredo, you better look at this patent. Let's see what else we got here. Student files. Okay. Right here. Sarisha. You're up.
Hi, good afternoon. I'm going to explain what my idea is. This one is dry superconducting magnetic motor. Like we have we have research going on superconducting motors right now. The first recently Cambridge University people have built this superconducting motor with permanent magnets, high temperature superconducting motor. But uh, I did some search on it, but I didn't find anything which works at dry ice temperatures. So I wanna continue with this idea like dry ice superconducting magnetic motors. Superconductivity is possible at driest temperature. The research has done in 2010 about this driest superconductivity at 195 K. 195 K is the temperature at which driest exists.
Can you translate that to Celsius for us?
Minus 30.
This is 273, is it? Celsius is 273 degrees below zero.
Zero, yeah.
Right? In Kelvin. 0 degrees Kelvin is 273 degrees below zero. Right?
Yeah.
And this is 195 degrees Kelvin. So we have to subtract that from 273, is it? So
195 minus 273.
So is it minus 70, is it?
78.
78? Minus 78C.
Yeah, it is.
So still cold.
Well,
But not as cold as the liquid nitrogen that people use for superconductors now. So it's a relatively high temperature. Easy to obtain with dry ice, I think.
so like superconductivity is possible with rare earth materials. They did some research on this. So superconductivity is possible at that temperature even too. With this, this is the one like SNPB, indium, barium. This one, I don't know about the scientific names exactly, but this one is the material that they use for getting superconductivity at driest temperatures. So I wanna continue with this idea to do motor using this superconducting material at driest temperature. These are the some of the patents available in like market, like something patent office, like superconducting materials. They did like how the superconducting materials are exhibiting that rare earth materials are exhibiting superconductivity, and the other one is homopolar inductor. This one generates, I mean, this one is the inductor alternative for power applications. Like they use superconducting magnets in this materials and magnets in that, and the other one is hybrid superconducting motor generator. This one is high temperature generator or motor. that uses superconducting coil and then permanent magnets. And the claims are like the structure that they recently built is like I told you the research was done in like driest temperatures. That one they use 1256 by 1212 structure to attain superconductivity at driest temperature. That's
So, American Superconductor sells superconducting motors. Are those superconducting motors all running at liquid nitrogen temperatures, or do they run some of them at dry ice temperatures too?
I I did some search on that. Driest superconducting motors are not available in right now because they have.
Oh, American Superconductor doesn't sell those motors now? Because
I
they're
guess
listed as a product, right?
I think so.
I sent you an email about it, so some correspondence, right?
Yeah, some corresponds, but they did some research for dry superconducting materials at driest superconducting possible at driest temperature. They didn't use that material too.
Okay, thank you. So here's what I thought, and I don't like to be the gloomy Gus because I love these ideas. I think they're great ideas. But if I wanted to go to YouTube and find some sort of a dry ice motor, I think I could find one, right? They must have these things: dry ice, superconducting. And I thought I saw one. Sometimes what people do with dry ice is they use the bubbles, the pressure, to power an air motor. But I could have sworn I saw a dry ice. Well, let's say maybe it's just a superconducting motor. If that's the case, then it's not the same. Yeah, this is superconducting motor. Yeah, so now this is what you're proposing, right? Fully high temperature. So is that dry ice? I think when they say high temperature, what do they mean? Oh, they use liquid nitrogen. So if it's liquid nitrogen, it's not really as high a temperature as you're thinking. Yeah, I think liquid nitrogen is quite a bit colder than CO2, than dry ice. I think liquid nitrogen is minus 170 degrees centigrade. Yeah, minus 173. And what you're thinking of is minus 70, so big difference. Yeah. Very good. So you're going to build this for us, right? In class? I'm very excited. I'll buy the dry ice, and you can do the other stuff. No, you have to do your part of the project. Let's see. Smart grid. Are we ready for the smart grid?
Smart grid, it is mainly used to effectively use power, and right now I'm doing it for the domestic use to find out the power at homes, usage of power in homes, because first I came with an idea of smart meters and they're prone to hacking. That's why I want to use per outlet power sensing, which gives us an exact idea of which device is using how much power. in this one, we'll have a bus bar which is connected to the outlet, and it will give us, it will have a digital signal on, it will have a digital meter which will give us the exact reading of how much power we are using. And then it will, we'll have a power monitor, and all the outlets will send the messages, like send the records to power monitor, and the power monitor will add all the records, and then it will send to central hub.
So what is a bus bar? Is that an outlet strip?
Yeah, outlet strip,
I see.
which will tell us the amount of power we used. And the smart grid works as the same thing. It will from the central hub, the same, the smart grid takes the usage of power, and then it will calculate how much we're using, and then it will effectively generate the power according to it. These are some of the patents. Power strip, the first one, it is done for the data centers and the companies. They're using it right now, and they'll have a power strip which will have so many bus bars, and then one server will be connected to it, and it is helpful in using the power effectively. And then the smart grid, it is this one, it is helpful for the blackouts. It will reduce the blackouts, and it will use the wind power and solar power, etc. And these are some of the claims. I just did it for the domestic usage of power, not for the entire project.
So, let me understand your first independent claim.
Yeah.
Anybody who does anything with a power outlet sensor for domestic use and outlet strips is going to infringe on your patent.
Like the same sensors, and because they don't have it outside.
They don't.
They don't. Like they have so many switches, like almost like 12 or 13. But if I have an outlet with 2 of them, I wanted to do it for only 2 of them. So that it will give you.
Does the bus bar know each individual outlet?
We have to do it like that. If an individual outlet has 2, then we have to make it according to it 2. Normally in a house it will contains mostly 3 or 4. That's it, not more than that. So if we do it for 4, it will be.
So it's not just a smart outlet, it's a smart outlet strip where each outlet can individually be metered.
Yeah.
And then all of the outlet strips communicate?
Yeah, with a sensor. And it will have.
Where's the communication part in your...
I did this in the 3rd one. The results in power monitor is the sum of all random values from power outlets.
So what you really need in here is something that indicates that there's communication going to a central hub.
I think I did it in the 2nd one. I didn't mention any sensors in.
Yeah, there's
I
no
didn't
hub
mention.
involved.
Yeah.
So are you going to claim maybe another independent claim method as in one where there's some kind of communication going on
Between those outlets.
between the various outlets and
Okay.
some sort of logging system that logs the power usage as a function of time, so that you can see when somebody turns on the electric dryer, because that might be a big consumer of power. And if you said to me, well, you know, I'm trying to figure out whether I should buy a gas dryer or an electric dryer, it might be really good to know how much money you're saving when you make the decision. So you can say, well, over the course of a year, it costs you 25 cents every time you run the dryer, because it's electric. And you run the dryer every other day. So, per year you're saving all that money. Sometimes gas dryers are even cheaper than electric, but sometimes not. Sometimes you have to have a plumber install gas line, then it's very expensive. Okay, thank you. Who's up next? This is very timely upload. JITHW, just in time homework. So you're sitting in the back doing your homework assignment. Okay. Go ahead. I'd love to. Oh, it's obvious? Yeah. Oh, it's okay. Tell us about why you're going to make it not obvious after you've done explaining.
I have no idea right now how to make it not an obvious.
Well, it's okay.
But though I'll
Take your time, but think fast.
but though I'll present it. I found it's obvious when I came here visiting professor after visiting professor. Okay, so I started my idea like this, noise, because previous one it was a different idea. I want to start from the beginning, so I'm presenting completely again. So noise pollution is the one. It's one of the biggest problems in metropolitan cities, where you have a lot of noise, and this is the reason that could make people feel stressed and lose their everything, mental ability and all that. So for that, the meditation and therapies are the quiet solution for those. So this is the idea that triggered me. I heard of an anechoic chamber called as world's quietest room in Orfield Labs in Minneapolis. It's a chamber where you'll feel completely quiet. It has an you can't hear anything. It's like it absorbs all your sound and everything. With that, I came up with this idea. I'm not implementing this absorbing echoes and all that. My concept is echo cancellation. Channel nullification. With this, I'll try to nullify the sound that is around me. It's just like I'll produce an anti-sound signal that nullifies the sound around me, and so that I don't get a sound inside my ear canal. How it works, and it's like I'll record the sound around my ear, and I'll invert the signal with the inverting circuit, and I'll amplify that signal to the scale that the sound is around here. So I'll combine both of them, where I get a feeling of no sound around me. And I presented it. It's like I felt it's not obvious before, but when I see this active noise cancellation and all that, it's really completely obvious idea. So this is my abstract description and claims how it works. Claims is I have a microphone around the ear area, which should be far enough to the earphone speaker, and polarity inversion circuit where chips 180 degrees my sound signal, and I'll combine both of them to get a zero or nullify the sound around me. That's it.
Okay, are there any comments? Good? No comments? Oh. Yes, I think so. What would we do if we were in the position where we wanted to make this non-obvious? What would make this non-obvious? We'd have to change the claim, right? We would need to make it somehow specific. We need to make it somehow address prior art. We need to create a synthesis of something new, an invention. So there's nothing wrong with doing an invention in, I'll say, active noise cancellation for headphones. But the invention part has to somehow make a contribution. And this is true also for a thesis in general. So if you told me you had a new algorithm for active noise cancellation and you were patenting the algorithm, that would be not obvious. That would be patentable and might even be a good thesis. Other than that, it's not clear. You know, you can patent the microphone if you have a special microphone. You can patent a special speaker, maybe some piezoelectric speaker that is able to withstand high pressure levels. It's not clear. Polarities and inversion. It sounds like you want to spaceship the audio.
Yeah.
So far, I think it's all quite obvious. And
Yeah.
you're going to have to go back to the drawing board to make sure that your stuff can withstand the next homework assignment, which is the self-assessment. Right? You're going to confront it with the office action, and I think it's not defensible. You have to alter
Yeah.
your claim. It's okay to be in this field. It's even fine to say you're going to do active noise cancellation headphones, even though they're already on the market. What you need to actually describe is the method for active noise cancellation that makes your contribution yours. Okay? Thank you. Next. I guess we're missing George here. Electricity. Raul, you're up.
Good afternoon, everyone. So, as I had presented my topic before, the concept name is Vitricity. So, I would like to present the title. It's like the wireless power transmission for the Arduino Mega AVR at Mega 2560 microcontroller. I have made so many Google patent search and USPTO search, and I found zero results. There was never a patent for this specific microcontroller of this Atmega 2560. It's of Atmel type, and this is the abstract of the presentation. So the main primary thing is that to power up the microcontroller wirelessly, so that we can use the microcontroller anywhere in the surrounding where in a surrounding where we can get the power wirelessly. So this involves a source, as I explained before, like um, we 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 power up the copper wirings or copper windings, so it produces a magnetic field, and if we have another copper windings of which are in the same resonance of the one which we had power, so that there might be a chance for power transmission, and we can power up the microcontroller and use it anywhere in the surroundings. So I found one of the patent which is similar but the application is different. It is the wireless energy transfer for the refrigerator. So I don't know why I could not find the patent number, but I just got this application number from the USPTO. I could not get the patent number. So, but this I mean I'm using the same concept, but the application is of different thing. Here they use they are powering up the refrigerator, whereas in my project I'm powering up the microcontroller Arduino AVR, and these are the claims.
Now, is your claim only going to work for this one kind of microcontroller and not for microprocessors in general?
Yeah, it might, but the process I am claiming about the process about how
So
the
you're not
power.
claiming the process. You're claiming that you have something that's just for this one microcontroller. And if I change
Okay.
microcontrollers, then I'm not infringing on the patent because you don't claim it. So if you want to broaden this claim, then it should be a wireless power system for microcontrollers.
Microcontrollers and microprocessors, or whatever it is.
Computational chips or something as broad as it can be. Unless you did your Google search and found that someone has already done something for microcontrollers.
So it would be like a wireless power transfer for microcontrollers and microprocessors kind of thing.
You know, I gotta say, if your patent only claims the 2560 mega AVR, as soon as that goes obsolete, your patent is useless. So you want to broaden your claim just a little bit, and shed this idea that it has to be an Atmel
For Arduino microcontrollers.
What if it's an Intel product? What if it's a Motorola product? Maybe it's a PIC microcontroller. I don't know. I mean, I'd like to say Microchip makes microcontrollers too. Doesn't this patent those? Or is that?
It should be. Yeah, I should actually change the.
Yeah,
I mean, it's not wise to put a name.
you don't want to manufacture and a model number
Yeah.
in your claim if you can avoid it. You might take this information and place it in the body of the patent description. Right? You might say, you implemented this in a preferred embodiment with the AVR Atmega 2560 microcontroller. But we could have tried it with the 324P or the 168P, or we could have used a microchip, or we could have used whatever. This idea should be broad enough so that in the preferred embodiment we use Arduino Uno, which doesn't even use the 2560. It uses a 324.
Yeah.
So,
I understand.
and the old Uno Milanoves use the 168.
Yes.
So everybody's changing model numbers all the time. This field moves fast.
So it should be like broad enough to comply all the things.
Besides, I'm not convinced that you want to power the Mega. The Mega is the high power one. You should probably be powering the Tiny, which is the low power one.
Yeah, but like
What's the power requirement for the Mega?
it operates from a frequency of 0 to 16 megahertz and
No,
for
power. Watts.
what? I not check with the
Right? Because
power
if you're doing
consumption.
power transfer,
Yes, yes.
I don't need to know about megahertz as much as I need to know about power. I know that if I'm in standby, we measure tiny AVR in nanowatts. 180 nanowatts when it's active.
We can actually calculate it because
nanowatts when it's in a standby state. AVR at Mega 2560. I have one at home, but we don't have any here in the lab. It's the way powerful high-end processor.
yeah, I know the voltage and current, so we can just multiply and get the.
You know the current?
Yeah, it's 500 microamps
100 microamps.
and
So that's at
4.5
5
volts.
volts.
Yes,
Right?
yes.
So it's
There's the low power when at the initial.
That's when it's in the quiescence state.
Yes.
What if it's active?
It would be like it goes up to 5.5 volts, 4.5 to 5.5, just varies
Yeah, but
within.
what's the current requirement in the active state?
It will be slightly more, but I don't think it will be like more.
Okay, thank you. Yeah, there's a I don't know if you're familiar with the AVR power. Well, I just so happens I was doing a lecture prep on this earlier, and if you look at something like Atmel, this is a family. These are all Atmels, right? They're the 25. I'm not even sure the 2560 made it onto this list, but you want to do something like the AT Tiny, the Atmel Tiny, because those are the real small ones. The Megas, these are the ones that consume way more power by orders of magnitude relative to the Tinies. So the Tiny is, like, if I remember rightly, in its stable point, in its quiet state, it's 0.026 nanowatts. And then if you want to, wake it up and have it do some sort of processing, it's like 180 nanowatts. So it's still small, and deliberately so. So I don't know. What about RFID tags? Right? Isn't there some kind of a processor in an RFID tag? And doesn't it wake up from wireless power? So it gets in proximity of what do they have, these bars by the doors when you walk outside, and then it starts to transmit back. So here it is. It's the size of a grain of rice, and it has an electromagnetic field coil, and it transfers a coded identification number to a reader. You can put it inside of pets. You can put it in, it says here, livestock. Walmart uses these things. Here's one from Toll Collection. I think these have lithium batteries in them. Passive. That's what you want. Receives radio signal and then responds, I guess. You want something with no battery. So there's a lot going on here. All these RFID tags have some kind of processor in them, because they're able to give a coded response when they get powered. And some of them are quite inexpensive in quantity. So I'd be real interested to know how your stuff compares with the stuff that's out there. It says here, dust-sized chips store 38-digit numbers. Of course, you're going to actually do some kind of processing. You're not just going to respond with some kind of a code. So it says here, Texas-based Device Fidelity develops special micro SD cards. You can also have a passive tag. Wow, who knew? They're in credit cards. MasterCard has RFID in them, so you can just swipe your card around the gas pump and pay for your gas. They're in passports. I'm not exactly sure how much processor is in an RFID chip. There may be a great deal more processor in the tiny chips of the Arduino than you would find in an RFID system. So RFID tags all have coils, and they're all powered inductively. So you're working with the witricity concept, I think. So some of what you're doing is been done, but other parts of it looks like maybe new. So it makes sense to sort of look at some of the RFID stuff. Here's an RFID tag designed by Walmart. You know, it might be fun to try fractal antennas. You know, there's a lot of people who are using fractal antenna design. And it's not clear to me that a fractal antenna design is the right thing to use. But you can kind of see they're very exotic designs. And if you can get a fractal antenna to induce energy because of its unique properties, it might make sense that you know, you can fabricate this as well as any on something like an epoxy substrate, printed circuit board. It's almost as interesting as, you know, as intricate as a microstrip array, except that it has that self-similarity associated with it. Does anybody use witricity with fractal antennas? Have you heard of fractal antennas before? Well, fractal antennas are considered mainstream practice now. And it looks like someone has talked about fractal antennas and wireless power transmission before. So this sounds like really cutting edge stuff because, look, it came out in 2012. So there's something to read. Interesting stuff. Fractal antennas proposed as energy source, 2009. I just think that's a very interesting idea because you can bring together these ideas about fractal antennas, which are very new, and wireless electricity, which is also relatively new. Put it together and you can create some means of powering, let's say, Arduinos with a shield. I think people would buy that. That sounds like a product. You should get a patent on this. Very good. I am now the official co-inventor. Right. Multi-band behavior of Sierpinski fractal antenna. Yeah, it sounds like something really different. So the use of fractal antennas for wireless electricity transmission for microprocessors. Ooh, I like it. So wireless fractal antenna goes in and Bluetooth power is coming back. And the Bluetooth has information about things like what you're thinking. It says, you're thinking of buying stuff. It's very good for shoppers. You put on your little Brainiac cap, the Arduino hat. It's good because it has a propeller on it to keep you cool. And then that's all powered by wireless electricity. I'm liking that idea because it's very geeky. And then part of the extra power that you can get, it powers the lights which go around your pocket protector. It's a chick magnet. Everybody will want you now because of your blinky lights. So I think this is a great idea. It certainly seems like a good Kickstarter project. And I think what we'll do now is let's take a little break